Welcome to my channel. In this session, we will discuss ratio proportion variation concepts second part. In this session, we will discuss the concepts of proportion. What is a proportion? If two ratios are equal, we say they are in proportion. Say if A is to B equals to C is to D, we say that A, B, C, D are in proportion. And if A is to B equals to C is to D, we say product of extremes A into D equals to product of means. How it comes? Basically, A is to B is nothing but A by B, C is to D is nothing but C by D. It's like cross multiplication. AD equals to BC. So if A is to B is equal to C is to D, product of extremes equals to product of means. A into D equals to B into C. Right. If A is to B or A by B, C is to D or C by D, then there are three important rules. First one is A plus B by B equals to C plus D by D. This is called Comprendo Method. How this comes? If you add both sides, since they are equal, if you add 1 to both sides, because they are equal, you can add the same number or subtract the same number. So now I'm adding 1 both sides. When you simplify, you'll get A plus B by B. This will be C plus D by D. Suppose if you subtract 1, you will get A minus B by B equals to C minus D by D. That is called Dividend Method. So A by B equals to C by D. By subtracting 1 both sides, we'll get this. And now that we know Comprendo Method and Dividend Method, the combination of these two is Comprendo Dividend Method. If I write first one by second one, B gets cancelled, here D gets cancelled. We'll have A plus B by A minus B equals to C plus D by C minus D. This is called Comprendo Dividendo Method. Very useful approach in simplifying especially some of those algebraic equations, right? Okay. Now then, what is continued proportion? If A is to B equals to B is to C, A, B, C are said to be in continued proportion. And for example, 3 is to 6 equals to 6 is to 12, because this is 1 is to 2, this is also 1 is to 2. So then we say that 3, 6, 12 are in continued proportion. Some of you may think, sir, is it not in geometric progression? Of course it is, because it is into 2 into 2, it is geometric progression. So this is synonymous with geometric progression. But anyhow, progressions we will take a different session. So in this session, we will continue with this proportion concept. If A is to B equals to B is to C, A, B, C are said to be in continued proportion. Now here, if I apply the product of extremes is equal to product of means, B square is equal to AC, or B is equal to square root of AC. And this B is called the mean proportional of A and C. Here the B is called mean proportional of A and C. And C is called the third proportional of A and B. If A is to B equals to B is to C, B is called the mean proportional of A and C, and C is called third proportional of A and B. Please remember, this third proportional term comes in continued proportion only. In the previous case, when I say if A is to B is equal to C is to D, here we don't call C as the third proportional of A and B. The third proportional term is used when A is to B equals to B is to C, then we say C is the third proportional of A and B. You may call D as fourth proportional of ABC, when if A is to B is equal to C is to D. But we don't call C as third proportional. Third proportional term is used in continued proportion. And as I said, continued proportion is synonymous with geometric progression, because if three numbers are in continued proportion, are they not in geometric progression? They are, right? Okay. Next, if I take 2 by 3, is it not equal to 4 by 6? It is also equal to, say, 6 by 9. They're all equal. 2 by 3, 4 by 6, 6 by 9. You cancel 2, you get 2 by 3. You cancel with 3, you get 2 by 3. Suppose if I add all these numerators, 2 plus 4 plus 6 by 3 plus 6 plus 9, how much it is? 12 by 18. 12 by 18 is nothing but 2 by 3. That is nothing but equal to the original fraction. So that's why we say if A by B equals to C by D equals to E by F and so on, A plus C, sum of the numerators and so on by sum of the denominators will be equal to original fraction itself, A by B. And this applies for even subtraction also. Suppose if I write 2 minus 4 minus 6 by 3 minus 6 minus 9, how much it will be? It will be minus 10 minus 8. It is minus 12. Minus minus gets cancelled. 8 by 12 is 2 by 3 or not? Yes. So this applies not only for addition, even for subtraction. Very useful rule again in simplifications of equations. Now, these are few important points on proportion. Now, we'll apply them and solve a few questions there. The first one, the ratio of the ages of two friends is 4:5 now. 2 years ago, the ratio of their ages was 7:9. Find their present ages. The ratio of ages of two friends is 4:5 now. Present ages of the two guys is 4x and 5x. Because they're in the ratio 4:5. If there are 4x and 5x now, 2 years back, 2 years ago, each one was 2 years younger, so 4x minus 2, 5x minus 2. But two years ago, the ratio of their ages was 7:9 means equate this to 7:9. You can say product of extremes is equal to product of means. 9 into 4x minus 2 equals to 7 into 5x minus 2. You can say 36x minus 18 equals to 35x minus 14. If x comes this side, x equals to 4. Once x equals to 4, now we are interested in their present ages. The present ages are 4x and 5x. 4 into 4 and 5 into 4, that is 16 and 20. This is our answer. Right? Let's take up one more. Incomes of Soras and Chand are in the ratio 5:4. Their expenses are in the ratio 3:2. If each one saves 6,000, find their incomes. Now here, incomes are in the ratio 5:4 means we can write incomes as 5x and 4x. The expenses, these are income of Soras and Chand. The expenses are in the ratio 3:2 means we can write expenses as 3y and 2y. Income minus expenditure will give savings. That savings is 6,000. 5x minus 3y is 6,000. Savings of Chand also is 6,000. 4x minus 2y equals to 6,000. When we solve these two equations, we get the answer. This is using simple equation concept. Or now, the second approach will be, we'll use the ratios concept only. Incomes of them are 5x and 4x. Now, there's each one saves 6,000. Now, the income minus savings will give expenditure. 5x minus 6,000 here, it is 4x minus 6,000. Now, the ratio equals to 3:2 means we can write product of extremes, product of means and get the answer. Here we are getting two variables and two equations. We are trying to get only one variable and one equation. If you multiply this with 2 into 5x, 10x minus 12,000 equals to 3 into 4x, 12x minus 18,000. 10x comes this side, 2x equals to 18,000 comes this side, 6,000, or x equals to 3,000. Once x equals to 3,000, their incomes are 5x and 4x means 3,000 is 15,000 because x is 3,000. And 3,000s will be 12,000. Right? Okay, this is second approach. And there is a shortcut here. If you observe, the incomes are in the ratio 5:4. The expenses are in the ratio 3:2. This is a special case. It's not possible all the time. It's possible here because what is the difference in the number of shares? 2 shares. Here also 2 shares. Both cases I have a difference of 2 shares. And both cases I have a difference of 6,000 between income and expenditure. Savings is nothing but difference between income and expenditure. Both cases I have a difference of 2 shares. Both cases I have 6,000 means I can say 2 shares worth is 6,000. 1 share worth is 3,000. So 5 shares worth will be 15,000. 4 shares worth is 12,000 I can say. Simple approach. So this is the shortcut. Done? Okay. Next, one more question. Mean proportional of two numbers is 12 and their third proportional is 96. Find the two numbers. Now, if the two numbers are A and B, Mean proportion of two numbers is 12 means what? If A is to B equals to B is to C, we call B as the mean proportion of A and C, I said. Now here, if I take two numbers as A and B, the mean proportion is 12 means A is to 12 is equal to 12 is to B. Then we say 12 is the mean proportion of A and B. Now, if I write product of extremes is equal to product of means, AB equals to 144. This is first equation. Now, their third proportional means, third proportional of A and B is 96 means A is to B is equal to B is to 96. Then we say 96 is the third proportional of A and B. As I said, if A is to B is equal to B is to C, C is the third proportional of A and B we discussed. Now, again if I write product of extremes equals to product of means B square. But now, in the place of A, I can write it as 144 by B here. If I substitute in the place of this A, the first equation, A equals to 144 by B. 144 by B into 96 equals to B square. B square goes other side, B cube equals to, this is 12 square into, this is 12 into 8. This is nothing but 12 cube into 8 is 2 cube. B cube equals to 12 cube into 2 cube means B is equal to 12 into 2, 24. Once B is 24, we said A is equal to 144 by B. A value is 144 by 24, 6. So hence, now the two numbers are 6 and 24. This is the answer. So these are few questions on proportion concepts. Right? In the next session, we will discuss variation concepts. Thank you.